Broadcast is now starting. All attendees are in listen-only mode.
Okay, so welcome to today's Advanced Design Twilight webinar. Today is the last in the series of Advanced Design Twilight Week, and we will be building upon the webinar which we covered yesterday for the Revit to FEM workflow. And today's one, it is a little bit similar, but this time it is called the Concrete Design Workflow using Revit and Advanced Design. So once again, I'm your host and your friend Jimmy Aldida, and I'll be hosting this webinar for you today. So I'm an application engineer here at Greytech, and I cover our simulate products for structures. And I'm responsible for providing webinars, training, demonstrations around our simulate products, and also providing technical support to our users. So before joining Greytech, I have served as a structural engineer for a number of years in the industry, and I've designed a variety of structures in many materials. You also have a copy of this handout, which is attached to this session. You can download this handout, and you also have direct links to my LinkedIn and also my email address. So please make sure to send me an email if you have any questions. And also, you can post any questions either in the questions pane or in the chat box. So this webinar is, again, it's going to be recorded, and we will upload it to our Greytech Content Center and add it to our library of webinars and content there, which will include things such as industry workflows, best practices, tips and tricks from some of our Autodesk and Greytech product experts, and all of this is for the AEC industry, manufacturing, and structures industry. As always, please allow up to 2 weeks for this webinar to be added to our content center. So if you've missed any of the previous webinars that we've been looking at this week, so anything from Monday to Thursday, in due time, in the next 2 weeks or so, please keep an eye on our Greytech Content Center where those webinars will be uploaded. Now let's have a look at an overview of what we'll be covering today in this webinar. So to start with, we will be exporting a model from Revit to Advanced Design. Now this model will contain an analytical model in Revit with loading, all the geometry and supports. We will then make some changes in Advanced Design to that model, and then look at synchronizing these back again with the original model in Revit. Once we've done that, we will then go back to Advanced Design and perform a finite element analysis along with a concrete analysis in Advanced Design. This will then allow us to open and design the elements using the design module in Advanced Design. So in Advanced Design, with the design module, we'll be able to design the reinforcement on some of the elements. Once we've completed that, we can then look at exporting this structure back to Revit, where we can once again have a look at those results in Revit also, and also calculate the elements reinforcement based on our results which you've obtained from Advanced Design. So that is what we have planned for today. I'm hoping you guys enjoy today's session, the final of the series of Advanced Design Twilight Week. So now let's get cracking. So yesterday we were looking at the workflow between Advanced Design and Revit for FEM. Okay. So here we can see if we can go from an original Revit model with this analytical model, okay, set of loads applied, and then export that to Advanced Design. And in Advanced Design, perform the FEM analysis, export that back to Revit, and then in Revit, calculate the reinforcement, generate reinforcement cages in there. So that's what we had a look at yesterday. So today it's going to be a little bit different. So the first few steps are similar. We're going again from Revit to Advanced Design, having a look at the FEM results. And then we're actually going to, this time, have a look at the design module. So designing the members using the advanced design modules, the concrete design module in Advanced Design, and then exporting that back to Revit. So let's see this in action. So here is a multi-story concrete structure in Revit. So you can see it consists of a variety of concrete elements that we have here. We have some columns, beams, slabs, and shear walls. So mostly grade C2530. We've also got some footings at the base of our columns that you can see here. In a second, I will also show you the analytical model, so we can see that there are loads applied. So let's have a look at the analytical model. And here we can see our analytical model. We can see the loads that we've applied to the slab. So here we have a live load applied of 1 kN squared to the slab. Now, with the PowerPack, as we discussed in our earlier sessions, we can export this model to Advanced Design. We can also import a model from Advanced Design using a GTCX. And finally, we can synchronize as well. In this case, today, we're going to automatically launch the model in Advanced Design. So let's now send this over to Advanced Design. So over to you, Advanced Design. And let's give this a chance to export. In this case, I had selected, I think, 1 or 2 elements. So it was asking if I want to export the selected element. If you want to export the whole structure, you have to make sure that nothing is selected. So we have some mapping here to do. If there are any elements which are unrecognized in Advanced Design or anything that needs to be mapped, you can map this. In this case, I'm going to map this to a C2530 grade concrete. Let's generate a report, and this will show us exactly which elements have been exported to Advanced Design. Now, here is the export log. So it's exported 80 beams, so columns, footings, and walls and columns, walls, slabs, and some loads. So we're expecting all of this to be transferred with the model into Advanced Design. So let's see how this is doing with Advanced Design. I'll give it a chance to load. I think it's on the other window here, so bear with me a second. There we are. Right, so here's our model now in Advanced Design. Okay, we can see the structure being exported across. Switch off the workplane. And here are our columns. It's 300 by 450 columns. If we expand the structure in the project browser here, we can see that the levels have also been exported to ground, first, second, and third floor. In this case, we also have ground, first, second, and third floor. So it carries through the same system. If you have the same system as Revit, it will carry those through to Advanced Design as well. So what we're going to do now is make some changes to this model. So to start with, I will let's select the columns at ground floor. Okay, so I'll select the columns at ground floor. At the moment, they're 300 by 450s. I'm just going to increase the size of these. We'll turn them into a square column. So go for a 600 square section here. So 600, and this is at ground floor only. So this is so we can recognize these changes, and I can show you how that works with Revit. So we've got some larger columns here at ground floor, we can see, and also see the items what we've changed. I'm going to also delete some elements as well. just to show you how that works. So I will also look at deleting some of the footings. Okay, so let's delete the ones on the corners here and see how Revit picks these up. Okay, so we have some changes now to this model. Now let's look at exporting this back to Revit. So on the way back, it's an export from Advanced Design. So export a GTCX file. So that's the common file both Revit and Advanced Design use to communicate with one another. Now you can see it's successfully exported the GTC file. It was exported on the Advanced Design side, and on the Revit side, we're still going to use the same model, and all we need to do is synchronize on this side. So no need to import a new model from scratch. We can use the same model and simply synchronize the changes that we just made in Advanced Design. So let's open this GTCX file. Okay, so you can see some items modified. 2 items have been deleted, namely those supports, and there aren't any FEM results or reinforcement available at this stage. So please note, you can see it says not available next to FEM results and reinforcement. We are yet to analyze the structure. So if I expand on some of these changes, okay, so more items have been modified because of the map. So I haven't quite mapped all the items. Okay, so if I go to parameters, the host, which was Revit, the size was 300 by 450. The GTC file value, which is what was exported from Advanced Design, is saying it's 600 square section. So that is how it usually shows the differences or the items which have changed. So let's select all of these and we'll accept first of all the modifications, and then we'll look at accepting the deleted items as well. So I'll apply these changes. Okay, so all of the columns to start with were 300 by 450s. So let's map this one. So it's picked up a new section size, 600 square. Okay, so 600, that's what we need. So once it loads, we'll have a look at these columns at the ground floor. Okay, so now I'll keep this window open because I also want to now synchronize deleted elements, which were namely the 2 footings on the corner there in Advanced Design. Okay, so if we have a look at, there we are, so rigid point supports were deleted. So what's changed? The host application value, there's a meter by 300. If I look at the GTC file value, it's 0. So that means there's nothing there in Advanced Design. Let's apply these changes as well. Yes. To the changes. So now you can see the deleted items are 0. 0 items now are deleted because I have synchronized what was deleted previously. So let's now have a look at what's changed in this model. Instantly we can notice the 2 missing footings there. Okay, so they've been removed. If I now hover over one of the columns at the floor here, so that is now a 600 square column, and the one above it still remains the same at 400. That one's a 400 square. Okay, so we've got the 600 square columns at the base there. Okay, so the ground floor columns and the supports have changed. So I'm now just going to put these supports back now because we need these to perform the analysis. So let's have a look at the analysis now. So now we're going to perform a finite element analysis along with the design for it as well. So we'll see design. Let's launch this. Okay. Finish checking, and now it's probably going to run through first of all the finite element analysis and then followed by the concrete analysis. So we can see on screen it's generated the mesh, and now it's going through the load cases, saving the results on the load cases. The command line in Advanced Design, you can see it shows exactly what is being calculated at each step. Okay, we can see the progress there. So once this, now it's going into the reinforced concrete design. Once the RC design has finished, we will have a look at just a couple of results for the RC analysis on some of the elements. We'll then open a column and a beam with the advanced design module, and then we'll design or calculate for the required reinforcement. So we'll provide some reinforcement using the design module, and then update the model in advanced design with that, and export the model along with the results back to Revit. Okay, so it looks like it's nearing the end now. So let's complete the analysis. So turn the mesh off, so I may not see any mesh or grid there with the results on the slab. So let's select this slab and choose, for example, area of reinforcement in the y direction at the bottom. So the maximum is around 800. We can see 792 millimeters squared a meter. Okay, so if we select now a beam as well, area of reinforcement in Z, so that is plus or minus 350. Okay, and what about columns? So we also have results for that. That's around the 200 mark, I'd say, 216-ish. Another type of result perhaps we could look at is the stresses. So the stresses in the concrete, relatively low there, 2 newtons a millimeter squared. Okay, so now with the analysis, you see you've got a set of results here. Now let's export this column. Let's open this with the advanced design module and then design this. Here we go. So now we can see our forces. That's what we designed for. Okay, so it needs to be able to resist these loads. So we can see we have many moments there. We have some axial and shear forces, internal efforts. So I'll give you a detailed breakdown. Let's generate these combinations now based on the load cases from the main model. Now it's simply running the calculation to see what reinforcement it provides. So we've got some reinforcement, but there are some warning messages at the bottom. So let's work through these first. So it's saying we need a class B or C of reinforcement. So over to the reinforced section and let's choose class B. requirements from the ductility class. Okay, so as per the Eurocode requirements, there we go, from 4.1.1. The next thing was to generate new mark combinations. So I'll just enable the new mark combinations and generate the combinations again to include the new marks. Okay, so we've got some more combinations now. Apply, and now let's rerun the calculation. Okay, so that's better. No warnings this time around. So it's saying 6 number, generally H12 bars that we have here. Okay, so these are the results. Longitude on top is very close at 100%. Right, so if we have a look at the 3D view of the reinforcement. Okay, so that's what this looks like. And then we have some additional bars going up to the top, connecting into the beam of the slab. Now, we can also modify the calculated reinforcement going into the main bars. So from the main bars, you can change the quantity. At the moment, it's 3 H12s, 3 by 3 for this column that you can see here. We can change the quantity, the diameter as well. We can also give it a hook angle. So starter bars, again, the starter bars at the top, the ones which are highlighted in yellow, it's 3 by 3. We can give this a hook if we wanted. Okay, and some offsets that we have there. What else do we have? We have secondary bars. No, we don't have them in this case. We have no bottom starter bars, since this is a ground floor column. Transverse reinforcement. So these links. At the moment, we have a package of 3 links. So I'll just show you how you can adapt this. So you can change it to one set of links at uniform spacing. You can have 2 sets or 3 sets or custom package even. So at the moment, it's a custom package based on what it's calculated. If I choose uniform, uniform then returns me with just one package, or actually a uniform spacing. So we can change the diameter as well. We've gone from 6 to 8 here. Okay. So there we go. Once I click apply, now it's left me with just one package. So they don't quite seem right. They're spaced very far apart. It's just to show you how we can then adapt the calculated reinforcement or amend it. So back into this, we need to add, perhaps change the distribution now. There's only 6 of them that you can see there. So the bottom offset, you can increase that as well. So at the top, the offset is a lot larger. There we go. So it's a similar offset now. But we'll just go back to 0.05. Since the base of the column really is at the bottom, we don't have any slab below that. We want to be, we have a lower offset at the bottom there. So 2 zones distribution, it will add 2 zones in. So to separate, you'll have 1 zone in the bottom and 1 for the rest of the beam. Okay, so we have, it's saying 6 links at the bottom, very close together, and then 6 throughout the rest of the column. There we go. You can see those 3 zones. We'll add another zone in again. And that's the spacing. You can see 100 millimeters. Whilst the others are spaced about 280. So notice how the spacing changed for the main transverse reinforcement as we changed the zones there. So let's run the calculation again. Okay, so no errors and warnings, we're fine with that. So that's a column, and we can also now do the same with the beam. So if we want to, we can close and update at this point, or close all. Updating it will ensure the model then is updated with the reinforcement. Closing it will just close it without saving any changes. So let's open a beam now. Okay, so here's the beam. Right, so again, let's generate our combinations and then we'll calculate the reinforcement on this. Again, the ductility class, we'll choose ductility class B. And now let's calculate and see what it returns. So it's returned again H12 bars. So 4 H12s at the top, and then we have 2 layers of H10s in the bottom. So 4 number in each layer. There is the detailed view on the reinforcement there for this beam. Okay, we have some sort of warning at the bottom, but in this case I'll just choose to ignore it. Let's update the model. So now you can see there's a tick next to 29 and element number 16, so it's being updated. Closing all means just closing without saving it in the reinforcement. Close and update will apply the reinforcement to the members in the global model. So let's close and update all. There we go. Okay, so notice that column size is also changed at the bottom now. There we go. Because we've updated all. Right. We also have a set of options for the application settings here. So we can export the forces, export theoretical reinforcement. In terms of the loads, we can export load cases and corresponding efforts. This time we'll do it with the list of combinations. So export another GTCX. This time we'll call this design. Okay, so advanced design with the concrete. So it's exporting the pen elements now, and then the results successful. Okay, so it's exported the GTCX file. If we look at the bottom here, the command line. Now let's head over to Revit, and we want to now synchronize these changes again. So we're bringing those results and reinforcement through to Revit now. And this time we also see the missing supports appear again once we synchronize. So if I open the GTCX file this time, when I first synchronized the changes, when we updated the column sizes and removed the footings, there weren't any FEM results reinforcement available. It just said some changes to the geometry. This time, if you look result packages, the FEM results are also available along with the reinforcement. So it has exported both of these things. Okay, so new 2 objects that we have for those supports which you added back in. There we go. Rigid point support. So let's see what's exported with the analysis. So it's in the other window. There we go. So it's imported FEM, internal forces, and we can do resultant forces as well. Let's accept these changes once again. Okay, so once this is finished synchronizing, we'll then look at calculating reinforcement using the information from Advanced Design. So we'll select a column and see the reinforcement on that. And then also we'll be able to see some calculation results in here as well. So very similar, you'll see similar functions here with the PowerPack. And that's available with the PowerPack design. So the PowerPack, you can see at the top here, there's PowerPack to import and export, and then general tools related to the geometry there. Then you have PowerPack detailing. Okay, so that's detailing and the reinforcement. So you can split rebar, modify the reinforcement cages. And then there's PowerPack design. The PowerPack design is very similar to what we saw with Advanced Design module when we had a look at that column and the beam. So both very similar. So it now should have, in this case, finished synchronizing. So if we go over to the PowerPack, and let's have a look at design status. So this will display the status of the element. So if I select the column now, and select this column, okay. So you can see now that size is, when we synchronized it, it's reverted back to the smaller size because when we calculated Advanced Design module, change the size. Okay, so let's select a beam column, for example. So here we have those two. This will display the reinforcement results. So let's first load the GTC file. Okay. So let's put the GTC file in here. You can do the same for the beam as well. Okay, so we've got an option now to run the calculation. If we can display reinforcement results, that will show you the reinforcement results on there. Okay, and if we go into here, you can see now this is very similar, or exactly the same, identical to what we were just looking at in Advanced Design with the design module. Okay, so related to the main longitudinal transverse reinforcement there. Let's run the calculation now. So it's saying status not calculated, so it hasn't calculated. Well, the results are there for it to calculate with, but we need to just run the calculation on this. There we go, it says calculated and it is okay. And you can see now the icons have changed. There's now an option to also generate a report from here. So you're essentially generating a report from Revit now. There we go. We can see the work ratio, calculation results are exactly the same as we saw in the Advanced Design module, the same representation. And then you can also view a diagram of the results as well. So let's open a diagram. And this is predominantly for the forces, so the moments and the forces. So you can see a bending moment diagram on that element. Okay, so you can see that here we're looking at the diagrams now. We just let it load. First off, we have the interaction curves. Again, this is exactly the same as we have with the design module. Same thing on both sides there. Over then to diagrams, we have a bending moment diagram. And we can choose our combinations as well. Okay, so predominantly axial loads on this. You can see shear moments are 0 value. And we can also see you've got the same, exactly the same tools here to modify the reinforcement. Okay, so it's exactly the same in that sense. I'll just close this so we can have a look at the reinforcement cage itself. Sorry, whoops, I think I'll skip too far there. So we're having a look at the reinforcement cage at the end there. just about finished doing that now. Okay, and with the PowerPack detailing, you can see you have all the tools at the top to then take this to the next level. Okay, so there you can see you can split the rebar, cage. You got define edge reinforcement, edit the rebar and the slabs. Really is quite detailed. So you're bringing analysis and also modeling together here with the PowerPack. So Advanced Design and Revit, you can use those both together to first of all model, obviously, and then analyze, and then design the concrete structure, and then modify that reinforcement and detail it in Revit, and then output ultimately the drawings, the finished product. So that brings us to the end of the webinar there. Before I close the session, I will just give you the opportunity to ask any questions. If you have any questions, once again, please pop these in the questions pane or the chat box, and I will pick these and answer your questions before I close the session. So now is the time to ask any questions. Okay, so I don't think we have any questions at this time. As I mentioned previously, if you do come up with any questions later, if you have any questions, please send me an email to jamil.dida@greytech.com, and I will get back to you with an answer to your email. So that then finishes the Advanced Design Twilight Week. Okay, so that's the end of the Twilight Week. So I'd like to thank you all for watching and joining me on these webinars for this past week. If you've missed any of them, head over to the Greytech Content Center. Within the next 2 weeks or so, we will upload the previous webinars. Once again, thanks for watching. Please follow us on social media, on our Twitter, Facebook, LinkedIn, and also our YouTube channel. It's bye from me. Thank you.